Okay, so today I will do the coding practice as usual. So today's question is on the binary search tree, and I've never solved this problem. So yeah, maybe I will take more time than usual. Yeah, basically usual. I solved a question I've solved before, but in this time, this is brand new question for me. Okay, so that being said, let me get started. Okay. So in this question, I will be given an integer array nums with no duplicate. Maximum binary tree can be built recursively from nums using the following algorithm. Maximum binary tree can be built. Create a root node whose value is the maximum value in nums. Recursively builds the rest of tree on the sub-array prefix to the left to the maximum value. Recursively builds the rest of tree on the subarray prefix to the left of the binary of the subarray prefix. And recursively builds the right subtree of the subarray prefix, no, subarray suffix to the right of the maximum value. I see. Return the maximum binary tree built from nums. Okay. So let me clarify the interface of the method I will implement first. So in this question, I will return the maximum binary tree built from them. Okay. I will give an integer and nums with no duplicate. Okay. And I will return the root of binary tree. Okay. So actually this question isn't about the binary search tree, but the binary tree question. Okay. So as the argument, I will be given nums, which is an integer array. Yeah. And probably when this nums array is an empty array, I will return num, or I should say null, because the tree is empty. So I will, yeah. Okay. Aside from that, everything is clear. So I will think of the algorithm with thinking some examples. So let me think of the examples that I'm given just say 1, 2, 8, 3, and 5. So in this case, when I take a look at this array, the maximum number is 8. So 8 will be the root of the tree, which is built. Then for the suffix is now 1, 2. So I will build the subtree with 1, 2 here as the left subtree. And as the right subtree, I will build some 3 from 3, 5. And when I got 1, 2, I will take a look at the left subtree first. So because the maximum number is 2, I can use 2 as the root node of this subtree. Then I have array subarray 1 as the suffix subarray is now empty array. So I will build the subarray with 1 and with empty array. Okay. Yeah. And for 3 and 5, this is the same. So I will pick 3 as the maximum number, and I will get 3 as the suffix and 5 as the prefix. No, 3 as prefix subarray and 5 as suffix subarray. And yeah, then I can build the subtree like this. And when I got this, I got both of them is empty subarray. So I actually don't have to build any subarray with this. And same for 3 and 5. Okay. So as a result, I will return, yes, I will build this tree and I will return the root node 8. Okay. So yeah, it's clear for me the algorithm I will be using. So I mean, recursively, okay, maybe, yeah, I can call this max binary tree recursively, and you know, if the given array is empty, I will just return none, and if there is any element in this given array, I will find the maximum one and make it as a root, and also I will build the subtree and I will connect it from the current root node. And after connecting left subtree and right subtree, I will use the recursion as well for that. And after that, I will return the right root node. So yeah, actually, okay, yeah. Actually, I can use this interface for the recursion as it is. However, every time I have to pass the subarray as I mean, if I pass the subarray as the argument of the recursive function, I have to create the subarray many times. So what I can do to avoid it is I will write the helper function, and this should be the recursive function. So I will define start and end index, and I will return the build subtree. Yeah. So with this being said, what I should do in the recursive function is, okay, so firstly find max, and then I will initiate root, and then I will call root.ref with, yeah, I can call it with helper, and also I will do it like this. Then I will return root. So this is what I'm expected to do. So in, okay, yeah. So now for me, it's very clear what I should do now. So I will clarify the time complexity and space complexity. So assuming the number of nodes is n, number of length of the array nums is n, the time complexity should be n times n squared. This is because, so I will call this recursive function n times because the build tree has exactly n nodes. And in each recursive function in line 26, I have to find the index of maximum number. So it will take, I have to look through all the element in the, given subarray. Yeah. So in the worst case, this traversal takes n time. So the total time complexity should be n squared. And for space complexity, so I will use the recursive function. And yeah, So just since the array is directly increasing, so in that case, the tree should be like 1, 2, 3, 4, 5, 6, 7, like a skewed linked list. So in this case, the recursive function calls tag. I mean, there would be n calls tag. So that's exactly the time space complexity it requires. Okay. This being said, I will work on the implementation. Or maybe I will think of some better, faster approach. Yeah, maybe there is. But let me first go with this. So I will think of the optimization later. I will implement the node class first. Okay. Then in line for the let me write the test cases first. So the first test case I have to cover is when given array is empty. In this case, it is expected that assert and every single one more some cases when the given array is strictly increasing. So in this case, it is expected that the some array should be, say, like the increase skewed. So no. So yeah, so in this case, I will get the tree first, and with that tree dot root num. Sorry, tree. This is root node. And yeah, so this is the expected value. Actually, I also have to check. I should also check if tree dot right dot left is num or tree dot left is num or some of the, yeah, or maybe tree dot right dot left is num or something like that. But let me omit that for now. Okay, and finally, I have to check the test case that, yeah, actually this is a happy path. So this is a quite typical case when like this. In this case, I expected it to be like this. So in this case, so 3 should 2, 3, let me go with this. So in this case, 3 should be chosen as the root node. Then for root 3 dot left, it should be 2 because it is the only remaining node. And for 3 to the right, it is expected to be 1. Okay. So yeah, okay. So let me write the code to the implementation. So as I said, I will define the helper method, and this will take this start index and end index. So definitely I should call this line 45 and so if ranks now is 0, I should return no first. Then from that, otherwise I will call this max binary tree helper and I will return the build tree. And for this line 47, this case, so what I should do, clarify is I have, yeah, if there isn't any range from which I should build the tree, I should return just none. So, and otherwise, I will find the index of the maximum number. So but I actually don't want to do this because if I do this, these nums left, right, +1 create another, you know, sub-array, another array, and it will take more space to proceed. So let me just traverse from left to right. So this number is Rogers and Max bar. I will update max index with current I, and also max bar should be num side. Yeah, so this way I get the max index here. So I will initiate the root node with, you know, that max value. Then I will call the max binary tree helper recursively in this way. Yeah. Then I will return root node. Okay. So let me double check. So yeah. In the case if end index is equal to the start index, what happens is that the max index should be, say, start, which is equal to end. So I will create the root node in line 58. Then, yeah, when I call the helper method recursively, it returns start and start minus 1 and end plus 1 and end. So in either case, yeah, the subtree is none. When I call the method recursively, it returns none. So yeah, it's okay, as expected. Okay. So this being said, let me quickly walk through the happy path 231 and yeah, confirm it. So when I got this, length number is now 3, so I will go to line 45 and I will call this function with start 0 and end 2. Yeah. Okay. So if I call this in line 50, in line 48, currently, yeah, and it is less than start, so I go to line 51, and I will start max index with, oh, out and end. Yep. So I will start this with max index 0, and start max value is now start, which is now 0. Oh, wait a minute. So how can I get access to nums? Oh, I have to pass it. Maybe I can make it a class and share the nums array as the instance variable. Yeah, easy is fine, I think. In this case, I will just pass the nums array as the argument. Okay. So with that being said, I will take a look at line 53. So this should start from 0 until 2. And I will start from 0. Okay, so because I is 0, now nums I, which is 0, isn't larger than max value. Yeah. This is always true because, yeah, actually I said max index and max bar with, yeah, that number. Okay, and after that, I will take a look at when I is 1. So in this time, nums 1 is now 3, which is larger than current max bar 2. Oh, this should. Okay. So max index is now 1 and max bar is now 3. Okay. And when I come back to line 53, now I is 2. And when I take a look at, yeah, max, now nums I is 1, which isn't larger than current max bar. So I go out of this if statement and also I go out of this for loop. So now I got max index is 1. So I will initiate yeah, node with max value 3. So this actually makes the node 3. Yeah. And this calls root left and root right with So because max index is now 1, I will call it with 0, 0. And also if because now right recursively calls for root dot right, and it should be 2, 2. Yeah. Okay. And after updating this root dot left and root dot right, it will return this node. Yeah, this node 3, and in the main method, yeah, original method, it returns that node. So actually this node is returned. Yeah, this node 3 is returned. Okay. And for max binary tree 0, 0, yeah, I will, yeah, omit, but this actually marks the index 0 as the max index and number 2 as the max value. So it creates the node 2. And actually this node doesn't have, you know, the left or right subtree, because once I got 0, it will call the method with 0 minus 1, and also this code with 3, 2. So in either way, this is none. And also for right, it return code it with 1, 0. And for here, this code right. So it will call the helper method recursively in this way. So this returns none. And this is also none. And same for this and this. Yeah, so actually this returns 3, whose node is root is 3, and left subtree is 2, and right subtree, right node is 1. So yeah, I'm pretty sure this is correct. I mean, the test case Brian 85 is correct. So yeah. Okay. So now I'm pretty sure that this code works. I will run this code. In line 76, sorry, I somehow called the helper method in the test cases. I will fix it. Oh, so in line 45, okay, I forgot to pass number array. So let me just quickly confirm. Okay, now it looks good to me. Okay. Oh, so line 79. Sorry. So because 3 should be the, okay. Line 78 failed. Obviously, this isn't correct. I mean, test case expected values are not correct, so I will fix it. So yep. Let me run this code again. 3, 2, 1. Okay. Yep. So the test case is passed. So I will run this code in the LeetCode platform. Okay, so the test case passed. So yeah, it was good. Okay.